Alright, let me show you how to use the Allegro Shader Toy. So you have to start it with one parameter, which is going to be the scene file that you want to use. And there's a bunch of scene files in the examples directory. We'll start with the oil slick example. And you can see that this is our tints entry earlier this year. And you can see that it's a beach and there are waves, but the waves have an iridescent sheen of oil pollution on them. And that's the shader effect. This whole scene is defined in this JSON file here, and it has references to several bitmaps and a shader code. So all of this is hot swappable. That means that I can open one of these bitmaps in my sprite editor, take the beach itself, and I can draw on it, save it, and it should take effect immediately as soon as I activate this window. I can take also the background layer, or so this layer determines with the magic pink color where in where the shader effect is applied. So if I draw with the same color like that, maybe draw a circle like that, and save it. Then you see that we have a hole appear here in the middle of the beach. And the same is true for the gradient. So this bitmap is used basically as a pattern, or the pattern of the reflections in the oil slick. And if we draw something here, maybe use a different color again. I draw here, save it, then that takes effect immediately as well. Okay, let's try another example. I'll try the example from Peppy, which is another speed hack game. And you can see basically it just consists of a screenshot from the game and this dissolve effect that's being applied to this rectangle here. You can open the definition here, and you can see that this is the definition of this scene. You can see that there is a bitmap, a screenshot that is placed. Then there is a shader object, and inside that shader object there is a rectangle object. And there is a JSON-ML definition for this schema, a JSON-ML schema definition, which means that it gives you a little bit of help with the meaning of all the properties. And it can even tell you the possible values. So for example, if I remove this and I type quote, it tells me that there's 4 possible values that I can put here. Furthermore, if I can make changes here. Let's move it over to the right. There you go, and I can make it bigger. Change the color. There you go. And all of that works. And if I accidentally make a mistake, well, then it pops up with an error. It tells you even which line number the problem is, usually. Not every error is equally meaningful. If I accidentally use the wrong type here, then I get this error, which is a bit too short perhaps. But all of that should help you make sure that the scene file is valid. All right, in the next example, which is from a speed hack game from last year, you can see that we have this really nice water effect in this platform level. And actually, during the speed hack, I didn't have time to properly implement this shader effect. But this is how I wanted it to be. If we open the shader definition itself, or the scene definition I should say, I can show the scene. I can also show the shader itself actually. There you go. Yeah, you can see that inside the shader, yeah, it's not that complicated. You can examine it in detail yourself. But there is one input parameter, uniform float water height, and that defines the water level, the level where the water is at. And this parameter can be configured from your scene file. So we take the scene file, and it says here that inside this shader configuration object, we can just add any parameters we like. We have to define which type they are and then the actual value. But if I change this, then you can see that the water level has changed. Change it like this, and now the water is lower. And so this way you can mimic what happens in the game when the water level changes. So the next example comes from yet another speed deck entry. And I'll open it first. And you can see that we have this twirl effect. That was used when you complete the level kind of swirls out. And the shader for that is here. It's another fragment shader. And let's take a look at how we would define another input parameter. So you can see here that there's a pivot which defines where in the screen or where in the texture the center of the twirl effect is. And if we could change that, and so like this, then it's more in the corner. Or we can take the other corner. We could make this configurable as well if we used a uniform. Let's call it, so we're going to make it, even though it's a two-dimensional vec or vector, we'll make the input one-dimensional. So we call it pivot. No, let's call it uniform pivot, and we'll use that here. But now this is an input parameter, and we have to define that in our scene. So we'll take the twirl scene, and the shader config is empty right now, but we can add a new one. It's going to be called pivot, and then it should be a float with value. Well, let's start with 0.5 again. There you go, and now it's back in the center. And if I change that here, now it's in the corner, and there's a little bug here because it's not removing old objects, but that should be okay. There you go. So that's how we add a new parameter. So for the final example, let's have a look at adding some text. So let's open the scene file. There you go. And you can see that I can also add shader effects to text. This is what the definition looks like. Here's the definition, the scene definition. And you can see that we have a shader object with a fragment shader and two children, which are text objects, 2 lines of text. So let's change that. Christmas is already passed, so let's change the wish here. There you go. Unfortunately, that bug that old objects aren't removed is still here. But you can still see that it takes effect. We can also change the font. So let's see, I have another font file that I can use here. So it's called Mountains of Christmas. Oh, no, that is not. It's called Mountains of Christmas bold. There you go. Okay, let's reset this to get rid of the old objects. There you go. Now let's have some fun with shaders. That was one of the sort of the assignments for this Krampus hack. So let's have fun with it. You can see that this is the fragment shader or pixel shader, and first we check if we're inside the texture. If not, then we just skip that pixel. Otherwise, we do some we do some calculations to decide which color we want. So we can either have I believe this is a red color or a green color in the bands, and then we also check if we are near the edge of the texture, and if that's the case, then we make it white, and we actually look for 4 pixels distance. If I change this, then the white lines, or the outlines, become thicker. Although you also should see some distortion at the corners because it's not very precise. Or thinner. There you go. And we can maybe play with these colors here. So here it just adds the X and the Y coordinate together, then adds the time parameter, and then takes the modulo of that, divides it in 2 bands, 2 equal bands. Let's change it to 3 bands. So let's say, let's define a new variable. I think it's going to be a float, but we'll find out. Intensity is calculated slightly differently depending on, let's see what happens here. So, right, we're already seeing some changes. Okay, let's go for a nice red, white and blue. So here we have red. Let's make this white, and then the final band should be blue. There you go. A nice, almost looks like a flag. And as you can see, it's very easy now to just try out new things in the pixel shader and see the effect immediately applied. So, in conclusion, I hope you enjoyed the Allegro Shader Toy.